Alright, hello guys. We're going to go ahead and try this again. Thank you to all of those who attempted to join our welcome webinar earlier. We had many technical difficulties, and I really apologize for taking up your time there. Thank you for bearing with me. I've decided to go ahead and make a recording for everyone to watch on their own time, and going forward I'll make sure that everything's set up properly and so we can have more of an interactive session. But I wanted to make sure I provided you guys with the webinar so you can move forward with the course and have an idea of what's to come. So first of all, my name is Stephen Barter. I will be your mentor. And a little bit about me. I am currently working for the UCF doing a data visualization bootcamp, and I was recently brought on to assist you guys in the data engineering course. I've been programming for about 3 years with an emphasis on data science. My passion is computer vision, and I hope to continue working on my skills in computer vision and one day eventually get into that field. But the one thing about data science is that it relies heavily on, of course, the data. So data engineering is a crucial aspect of the data science field, and without it there would be no progress. So with that said, I'm going to go ahead and we're going to go to the Udacity page. I'm going to kind of show you guys what are some of the resources that are at your disposal and what's going to help you moving forward in the course. Give you some recommendations of what assisted me when I was in my nano degree program. I was in the data analyst course. It was a great experience. I learned so much, and it really gives you some real life experience as to what you can expect in the workplace. So with that said, let's go ahead and dive in. I'm going to switch to interactive now, and let's hope that this audio doesn't fail like last time. Alright, here we go. So looks like the audio is good. Great. So now I'm just going to jump over here. So this is my homepage for the data analyst course. So as you can see, the lessons are broken down here on the left. Each section is labeled with a number. So if we were to click here, we will see that here's all the courses that are part of the introduction to data analysis part. Eventually, at the end, there's always going to be the project for each section. So as you guys are progressing through the course, you will be able to go over here to the Student Hub. And in the Student Hub, you will find other students who are also working on similar issues. And it will be a great resource for you all as you move forward in the course, because your fellow students will be encountering the same issues, and many of them may have already solved them. So if you get hung up on the problem and you're just stuck for hours, always check here, reach out, ask questions, and of course you can always reach out to me. You have the Slack channel as well, so there's a few different options for you guys as far as reaching out reaching out to fellow students and getting help. So next I'm going to show you guys the Knowledge Center. So since you guys are going to be the first cohort for data engineering, this may not be the best resource for you all, but we're kind of depending on you to get this going. So as you can see, we have lots of past students here, and what they're doing, it's almost like the Stack Overflow of Udacity, where people will post questions and people will come and answer them. What was especially useful for this is, for example, I was working on a project that required us to use an API to contact Twitter, and I was getting some it was a data error. Basically, I was making too many API requests, and I could not for the life of me figure out how I could get around this. So eventually I tracked this down. So for example, we'll go ahead and say parsing JSON error, and what will come up is all of the students who have had similar issues. You may have to scroll through, find the one that's completely relevant to what you're working on, but As I said, you guys are going to be the first cohort for data engineering, so you may not be able to find your answer immediately, but it would be great if all of you can join that and start filling this up with information for all of those who will come after you. Excuse me. Okay, so those are the two most important resources that I wanted to share with you on the Udacity page. These other 4 tabs we got here, we have the careers portal for all of you that are going to be looking for that next step in your career. We'll take a brief look in here. Udacity offered me many options such as resume review. They offered sources to services where we can do mock interviews. That's great practice for when you're preparing for that next big step in your career. Also at the end they have the Udacity Career Network. So they reach out to many companies and let them know that we have alumni that are currently looking for work, and they put you in the pool. They give them you give them your resume, and companies will reach out to Udacity and they'll look for that perfect fit for them. And if you stand out, luckily we'll be building lots of projects that will actually act as your portfolio to show your work done, and that is how Udacity helps you link up with that career of your dreams. So I recommend going through here, checking out all of the resources. Definitely utilize as much of this as you can. Make sure you get the most out of your nano degree. And over here we just have if you want to look at all of the different courses that Udacity offers, you can come over here to the catalog. There's many free courses that are actually very good. One of my favorites was the Fundamentals of Statistics course, and honestly it was probably the best statistics tutorials that I've found for basic entry-level statistics stuff, or even if you just need a refresher. Sebastian did an amazing job creating that course for us. So yeah, browse around, find what you find interesting, and it doesn't hurt to always supplement what you already know with more knowledge, because you never know where they might intertwine. Excuse me. Okay, so now that I've given you a brief tour of what Udacity has to offer, I want to go ahead and we're just going to jump into deep waters here, and I'm going to show you making a relational database in Postgres. So first you'll want to open your start menu and open up pgadmin. That's going to create a tab in your browser that shows the pgadmin GUI. So once you have that open, we can go ahead and jump up into our Jupyter notebook and we'll go ahead and get to it. So we're going to be importing and utilizing the scicop G2 library. What scicop G2 does is it acts as an intermediary between Python and Postgres, and it allows us to use Python code to interact with our Postgres database. Our second line here is just me loading my password from a different folder, that way that it's not visible to all those who view this file. I recommend you guys do the same. It's just good practice. And so next I'm just saying my password equals to password. And so now we'll move on to the first steps. So what we need to do is we need to make a connection to the database using scicop G2, and it's provided by this scicop G2.connect function. So it expects 4 arguments. You have to write in host equals host, the database name equals database name, user equals user, and password equals password. Next, you have to set the session auto commit equals true. That will make sure that as soon as you make changes, it will automatically do this for them. Next, we make a cursor. The cursor acts as the tool that will actually perform the queries and actions that we are trying to do. So I decided to, since we're going to be doing this so often and within every file, I wanted to make this in a function to reduce the amount of code I have to write, as well as just make things easier. So one more thing I'll explain is we wrap this in the try except statement. So what this is doing is it's saying try to make the connection, set the session, and create a cursor. If there's an error, for example, I put in the wrong DB name, I provided the wrong password, we will raise an exception, scopg2.error as E, and we'll print that error. Finally, we're going to return the connection and the cursor. So when I call this function, I have to assign it to the two variables, connection and cursor equals connect and make cursor, and then I provide the information I needed. Here the user, Postgres, it was the default name of the user as I installed Postgres. I'm not sure if that will be the same on your system, but just make note of that. Okay, so now that we've created a connection to Postgres, what I want to do is I want to create my own database. I'm going to call it AcmeCo. So in order to do that, luckily SQL really follows almost plain English. So the syntax for that is we're going to use our cursor, say cur.execute, and then we're going to put in our query, create database AcmeCo. So AcmeCo will be the name of our database, and then these are the two keywords that we needed, create database. Easy enough, right? Okay, so next I create another helper function here, which closes both the cursor and the connection in that order. So simply cur.close, connection.close. Then I call the close connection function. It does not expect any arguments. You just call it with your parentheses, and it will perform those two actions. So the reason I'm doing that is because originally we connected to the Postgres database, and now I want to reconnect to AcmeCo. So once again, I do con cur equals connect and make cursor, and then instead of including Postgres in there like we did in the first one, I'm going to put AcmeCo, the database which I want to connect to this time. And then we make that connection again. Okay, so now that we're connected to our AcmeCo database, we want to start creating tables, inserting our columns, and start adding data to it. So first, what I wanted to showcase here is, say if we were trying to create 6 tables for this database. This would be the syntax for doing so. We want to wrap it in our try statement, do cursor.execute, create table if not exist, table name, and then here I have just blank parentheses. If you were wanting to do a simple inline create table query, what would be included here would be the column names and the data types. So you could include those in there as well, but in my case I created another function which we'll see shortly that adds those columns and everything in later. I just felt like it would be better to make this a modular process for any future issues. Anyways, so what I wanted to show here was that in order to create 6 tables, this was the amount of code we would have to write. It's not anything crazy, but if you can imagine, this will start to add up. So next I wanted to show you the functional approach to doing so. So what I did is I created a new function called create table. It's going to take the table name argument. Table name equals the name of the table which you would like to create. Next, we have our try except statement, and within it we have our cursor.execute, create table if not exist, table name. And what I'm doing here, if you're unfamiliar with Python, you'll notice that I'm having this f before my string. So what that's called is an f string. The f string allows you to insert custom variables within a string. So the double quotes wrapped around this indicate that it's a string. In a normal string, if I were to remove that f, it would just write this out as is and not refer the argument that I'm including in this function. Because this is going to be, I'm going to be making multiple tables. I'm going to be changing this variable table name many times. I can't have it be the same thing every time. That's the benefit of functional programming. So just a little background on that. So next, what I want to do is I want to create a list here. And lists in Python are indicated by these square brackets. So it's 2 square brackets enclosing the data. Each one of these is an index of the list. So I'm creating the 6 table names, which I'm going to put in to the create table function. And then using a simple for loop, I say for table in tables, create table table. So to break that down a little bit, if you're unfamiliar with for loops, what it's doing is it's saying for each object within this table's list, call the create table function up here and include each one of these objects. So what it's doing is it's going through every single one of those, running 6 times this function. So now that we've done that, the next step, as I said, we didn't include the columns in our initial call. So what I have done here is I've created an insert columns table, or I'm sorry, insert columns function. This one's going to require 2 arguments, table name and call type dict. So it's column type dict. So table name is the name of the table to insert the columns, and column type dict equals a Python dictionary containing key value pairs of column name and column type. So we do our try and we say for column name type. You'll notice that I'm using this underscore here because the word type in Python is actually a Python keyword. It wouldn't allow me to use that. So this is kind of a common convention. If you're trying to use a word that's already a keyword in Python, common convention, you may see underscores afterwards. Anyways, moving on. So for column name type, in column type dict dot items. So I'm calling this dot items method because what that will do is it will return both the key and the value from the dictionary. If you were to try and just iterate over that column type dict, it would only return the keys. So to kind of better visualize this, this is our column. This is the dictionary I'm going to create down here called employee columns. It has the column name, employee ID, and then this is going to be the type over here. So this is the key, this is the value, this is the relationship. Employee ID is the key of the serial primary key. Just as first name is the key here, and here's the value associated with first name. In our case, it's the type of the column. So that's the use case for dictionaries. When you want to have a key value pair, a relationship between 2 different items. And this could be anything, the value. It could, in our case, it's a string indicated by these quotes, but it could be a list, it could be an array, it could be another dictionary. It could be, luckily Python is very flexible in how you can use data types. So let's go back up here to the function. So we returning our key and value from the dictionary, and we're going to say cursor.execute alter table, table name, add column if not exist. And then here we're including the column name, and then we have to include the type. And then we have our accept statement. So what's important to pay attention to here is the alter keyword. So when we're changing a table, we're adding columns, we're going to be for example, if we want to change the type of a column, this is going to be the keyword that you would use, alter. We'll see examples of that later. Okay, so moving on. So to insert the columns, we want to say insert columns, call our function. We say we want to insert them into the employee table, and then this is going to be the key value pairs, employee columns. So now I've already called this, just so you guys know, I've already run all this code just to make sure that I don't run into any hiccups and run the same cells twice and end up getting some strange errors. I just wanted to make sure that I ran the code completely and just make it kind of flawless for the presentation. So if you're wondering why I'm not running any of these cells, I assure you they work, and I have provided a link to this exact Jupyter Notebook on my GitHub. So if you guys want to dig through it and play around with it yourself, I highly recommend you do. Feel free to just copy paste these functions. If you can think of better ways to utilize them, feel free to make some changes yourself. But I just thought I would try and provide you guys these helper functions to kind of help you through the course and reduce the amount of writing you're going to have to do. That said, I can't stress enough how important it is to learn the syntax. So I was on the fence if I wanted to show you guys this functional method as opposed to writing everything out like this, because writing every one of these lines, it's going to get burned into your memory. So I do recommend that you really get comfortable with these different keywords, how to create tables, how to create columns, and so on. But I just wanted to kind of take you guys to a higher level here and show you what's possible. So sorry about that tangent there. We're going to get back to where we were. So now that we've inserted our columns, we don't get anything returned. We don't have any rows in there, so if we were to do a select all statement, it's not going to return anything. So what I want to just do is I want to make sure that all of my columns were added appropriately. So what I've done here is I've created a function called getColumnInfo. All you have to do is provide the table name. It runs this query, select column name, data type, character maximum length from information schema.columns. So this one's really important, the information schema. This is a keyword that will give you lots of information about your databases, your tables, because if you're working on something that you're unfamiliar with, this is going to be how you will access all of the information you need in order to find out which columns take what type, what the table names are, and so on. So let's continue. We have from information schema.columns, where table name equals table name. So that's where it takes the argument defined in the function. And so one thing I just want to say here, so these single quotation marks, so whenever you're specifying a value or a column that you want to change, I'm sorry, not a column, but a value when you're querying on, Postgres expects it to be in single quotes. So just make note of that. It's one of the trickier things about Postgres is just learning these small, subtle syntax conventions. So once again, we select column name, data type, character maximum length from information schema.columns, where table name equals table name. We do our accept, and then we return cursor.fetchAll. So cursor.fetchAll, what it does is, so the cursor does the execute, and basically what it does is it stores the the information returned from this query, it kind of stores it in the cursor. And in order to retrieve it, you must use this method here, fetch all. There's also fetch one, but in our case we want to return everything. So when we call this function, get column info on employee, we can see all of our columns, we can see all of the types that were assigned to them. So I just want to go over now the different data types that were assigned to the columns. So for our employee ID, we said that we want to give it the type serial primary key. So I'm not sure how familiar you are with other SQL languages, but serial acts as what's called auto increment in other SQL languages. So what it does is it creates a number. So the very first employee that is added to that column will automatically be given a 1. The next employee will automatically be given a 2, and so on. So it increments by 1 every time. And what that does is it makes sure that every value is unique. And then we also provided the primary key to that column, so that is going to be the unique identifier for every single one of those rows that we're going to input. So that is one of the fundamental tools of a relational database. This is how we're going to make our relations and keep everything structured in such a way that there's no redundant information, everything is orderly, and there is no conflicts in our data. So next we're going to go over we assigned varchar the first name. So varchar is variable character. So what that means is that it can take letters, it can take numbers, it could take asterisks. It's just basically text. And we can see that we've done that for first name, last name, position. Okay, so start date, that's where we switch something up. So for start date, I wanted to have a date type, because when working with dates, we'll be able to do certain calculations, computations that would be otherwise unavailable if we were to use just a simple varchar. So I set date, and what I also added was the default current date. So what that will do is when a new employee is added to the database, it will check the current date off the computer and automatically assign it. So kind of similar to series, but instead of auto incrementing or anything like that, it's just it's keeps track of where it's at and automatically puts the values in for you. Next, we have our phone, which is varchar, email, which is varchar. Okay, so we've gone over some of the simple data types. All right, so here we are. We've got our columns. All right, so yeah, now that we've got our tables are created, columns defined, let's look at inserting rows without functions. So this is actually the one that really made me think that I need to make a functional approach to this. So let's go over the syntax here. So in order to create rows, we use the insert keyword, and we say insert into the table name. We have the columns here, ID, name, contact, position. Then you say values, and what these are placeholders. These are what's called magic symbols in Python. So it's basically saying that this is going to be another value, which is going to be defined afterwards. So we have our %sign s, %sign s, %sign s, and so it's saying that there's going to be 4 values that it's expecting. And then over here, we include those 4 values. So that's just one row. So databases contain millions of rows in some cases. So it would be an extremely amount of information to have to input into the database if you wanted to create such a large large database. So as you can see here, I did a few examples. You can see that it takes up a significant amount of time just to write all these out, strange syntax. So I went ahead and, of course, created a function for it. So our function is called insert rows. It's going to take the table name, it's going to take the columns and the data. So like here we have our columns, and then here we have our data. And I'll walk you guys through this. So first I had to create a count variable. So what I did was I basically called length on the data. So what length does is it tells you how many items are contained within that. So what we're doing is we're passing it a tuple, and it's going to count. If I have 4 values, it's going to return 4 and assign it to this count variable. And then we do our insert into table name, provide the columns, values, and then we have our, this is where things got really funky with this function. So we had our placeholders here, and because of the strange syntax of it, I had multiplied it by the count. So what it's doing is it's creating however many data points we're making and multiplying it by that placeholder. And then we have to add that final closing parentheses. But if you notice here, there's a comma after the S. So when I multiplied it, the very last one had a comma. And that provided returned errors from Scicop because it does not expect a comma on that very last placeholder, because then it's basically saying that it expects something to be after that. So I had to do this little funky hack here where I take the query, which is this, the string, and then I reversed it using this the colon -1, which returns the string in reverse. And then I called dot replace method. So what it's saying is reverse the string, then replace the comma, replace it with nothing, and only do that on the first one. So now that I've done that, it gets rid of that trailing comma that was causing the issues. And then finally, I want to reverse it again and get it back to normal. Now we can say cursor.execute query, which is this, so it's query.execute, insert into table name, the columns, the values, and then finally it provides the data, which is what this was up here, the actual data that we want to insert into the table. So once again, I just want to show you how much code it would have taken, but now that we have the function, what we do is we create a list which stores tuples. So this has 5 tuples in it, which is going to represent our staff. We have, Bob Smith, president, phone number, and then his email. So one more thing I want to say here. So since we use the serial, it's automatically adding those numbers. So you don't need to include any value to give to that table, because it already knows it's going to say this is 1, this is 2, this is 3. So you don't have to include that, just so you know. As well as the date, as you can notice. Both of those are automatically added, so just to save you some confusion if you guys got confused about that. So now we say for employee, in employee list, insert rows into employee. These are going to be the column names, and then we insert the data. So now we can go ahead and start doing select all from employee. And then once again, use cursor.fetchAll to return that information. Alright, so I broke my rule and I ran that line of code. So this is what I was trying to showcase. I meant to say, whoops, the start date is wrong for our president and vice president. Let's update these values. So in order to change a specific, if we input the wrong data basically for one of our columns and we wanted to change it, we were going to use the update keyword. So the syntax for that is going to be update table name, set the column equal to the data which you want to change it to, where the condition. So you could say where first name equals Bob, where date is greater than June 23rd, or any kind of logical conditional you can think of, basically. One of the beautiful things about SQL is that it's just so close to plain English, where you can really break down problems in such a simple way if you really just kind of think through things. So one interesting thing about this function I want to include is I wanted to provide two different use cases. So we have one where there is that extra filter using the conditional, and then one where there isn't. So what I did was I said if the condition is not equal to none, where up here, so in my arguments I said condition equals none. So what that does is it makes it kind of optional. It's basically a placeholder of sorts. So it's just saying that you could include this as an argument if you want to or if you need to. So if condition not equal to none, we include the where and then include the condition, else we try and do it without it. So we go ahead and we update our row, we provide the table name, we want to set the start date equal to 2019-01-23, where the last name equals Smith, because that was the vice president and president. So once we run that, we return, we see that all of the other ones were given the date of 4/2, and now we have changed Bob Smith and Jane Smith to January 23rd. Alright, now to extract our sales staff data in order to create our sales department table. So cursor.execute, select employee ID from employee where position equals sales. We assign the fetch all to a variable. So now within that sales staff variable, we have the two employee IDs of our sales staff. Yeah, it's a small staff, guys. I'm just trying to make an example here. Anyways, so we're going to be following the same process as we did before, where we make the key value pairs. We have our column name, we have the type. So this time we're going to use int primary key. Total sales is going to be an int. We have region, which is varchar. We insert the columns, make sure that those columns are actually created using our get column info. Next, we provide the data that we're going to input into a sales list variable, and then we go ahead and use a for loop to insert those rows. Then we do a select all from sales department to ensure that those rows were inserted properly. And as you can see, here we are. We have our two sales reps. So now, to kind of showcase what a relational database is all about. So in our sales staff table, or I'm sorry, sales department, we can see we just have the employee ID, the total sales. There is no name associated with them. It's just an employee ID. So in order to return a query that would say show let's see what we did here. We want to see the total sales and the name associated with them. So in order to do that, we're going to have to join our employee table and the sales department table. And so we do our cursor.execute, select employee.firstname, employee.lastname. So that's saying first name is associated with employee, last name is associated with employee. And then we're also going to select the sales department.total sales from employee, inner join sales department on sales department.employee ID is equal to the employee.employee ID. Because those two values are the same, they are what is the commonality between the two. You can think of an inner join as a Venn diagram where the two circles overlap. So it's that middle area where they both have things in common. So now we do our cursor.fetchAll. And as you can see, we are returned the names of our employees and their total sales. So now we're going to go ahead and create an ID department. We're going to do something a little different here with the data type, which we will see that we will definitely regret later on. So we're going through the same process here again. We have our int primary key. We're including the employee ID. So this is where we kind of change it up. I input a column of skills, and it will contain various programming languages. So what I said here is that I want to set the type to text, and I include these square brackets, which indicates that it's going to be an array. So an array can contain multiple values, and the one catch is that they must all be the same data type. You can also include a second pair of square brackets, which then makes it a two-dimensional array. So if you were to think of, kind of a rectangle data object, such as like a data frame, a matrix kind of thing. Anyways, so now we have also a new data type here, bool. So bool is Boolean, true or false. So we're saying if the employee is remote, we wanted to say true, otherwise we'll say false. So we go ahead, we insert our columns. IT department is IT columns. Make sure that they were input. As you can see, now we have our array, we have a Boolean. Now we're going to insert some rows. So in our case, we only had our one employee. Old Tom is holding it down for the IT department. And we are inputting that information. When we do our select all, we can see we get our employee ID, we get all the languages that he knows, and he indeed does work remote. So, one of the interesting things about querying arrays is, so if we were looking for an individual that knew Python, or all individuals that knew Python in the case that we had more than one employee, we would say select all from IT department where the language that we're looking for, so where Python equals any of skills. So it's saying we're looking for this object and we want it, if any of them are in skills, return it. And so what it does, because we did select all, it returns the entire row. Okay, so let's move on here. Now we're creating a customers table. This time we're giving them a customer ID. We're using our serial keyword again to make sure that that's just an auto-incremented integer. Set that as the primary key. We have the first name varchar, last name varchar. So here we have salesman. This is going to be an int that references the sales department employee ID. So what that's doing is creating what's called a foreign key in many other SQL languages. So what that does is it reduces the chance for it makes sure that there actually is a relationship between a salesman and that customer. So we don't want to say that maybe Tom sold them something. We want to make sure that those numbers match up and that there aren't any made up numbers or any conflicts of it. And it will make it easier to make those relationships between our two tables. It keeps things very orderly, and that's one of the beautiful parts and why relational databases are used so much. So lastly, we have contact, which is varchar. Next, we create our customers. And once again, using a simple for loop, we can insert all those rows with 2 lines of code. And as you can see here, we return our values from the customers table. So now we're going to create a sales table. So what this is going to show all of the information. So it's going to have an order ID, a customer ID, the person who bought it. We're going to make that a foreign key that references the customer ID from customers. We're going to have a purchase total items in that sale. Salesman ID is an int that references the sales department employee ID. And then a description, which is going to be an array, including all of the items that they bought. So once again, we insert the columns, create the columns of the table. We create our dummy data that we're going to insert as rows. Do our for loop for sale and dummy sales, insert the rows, provide the column names, and then the data. Now we can see here that our columns were created. We do a select all from sales, and we can see we now have our 2 orders. So now we're going to do a calculation of the average purchase total from sales. And what I'm also doing is I'm rounding it down, because what this returned was many decimal lengths. So I wanted to clean it up and just reduce it to 2. So it's saying round the average purchase total to 2 decimal places from sales. And then when we fetch all, it returns this decimal of 900.00. So now we will query all purchase descriptions sold, salesman first, and last name associated with the purchase and the region from which they work. This will require 2 joins. So this is further showcasing how you're going to have to traverse sometimes through information in a relational database. Because maybe one table only has a relationship with, so from A to B, but A doesn't have a connection to C. So in order to get to C, you first have to join B on A. B contains the connection to C, so then you can finally get from B to C. Sorry if that sounded very confusing, but hopefully this will make it a little more clear for you. So we select sales.description, sales.total items, sales.region, sales department.region, employee first name, employee.last name. From sales, we interjoin the sales department on the sales.salesman ID equals sales department.employee ID. See, those were the foreign key and primary key relationship. And then we do the interjoin employee on sales department.employee ID equals employee.employee ID. And that was the relationship between those 2. Next, we call our cursor.fetchAll. So here we have the description of what they purchased. We have the total items that were included in that purchase, the region of the salesperson that works there, and then their name. So we're creating an inventory column now, an inventory table. We're once again using a serial, assigning that as our primary key. We're doing item name. We're going to give it a Boolean for in stock or not, and then total of items in the inventory will be an int. Okay, so once again, same process. Insert the columns, make sure that those columns were there. Okay, so here, whoops, I forgot to add our wholesale price and retail price columns in the inventory. Luckily, our function can easily update the table. So here, we insert our columns again using our function very quickly. We can just go ahead and add those on. So it's good that we caught that before, because otherwise we would have had to go in and update every single one of those rows. I may have already said this, but one of the most important things that you should walk away from this with is that planning is important when creating a database. You must think about how you're going to be querying this database, what the relationships are going to be, and so on. So, in fact, I actually drew all this out on a piece of paper, and I recommend you guys do the same. Try and get a visual of how this relationship of your database is going to work beforehand, because as you see later, we're actually going to run into some issues. So I'm not going to repeat all this again. It's the same deal. We're inputting our rows, and okay, so we've created our 6-table database. So now we're going to discuss the normal form. Normalization is the process of minimizing redundancy from a relation or set of relations. Redundancy in relation may cause insertion, deletion, and updation anomalies, so it helps to minimize the redundancy in relations. Normal forms are used to eliminate or reduce redundancy in database tables. So first, normal form. So what this is, it's kind of like a hierarchy, where there's first normal form. There's 6 normal forms. In practice, in production, there's people usually only get the 3rd normal form. 4th, 5th, and 6th are mainly for academic purposes. So we're just going to discuss those first 3 in this. So I'll read on here. If a relation contains composite or multi-valued attribute, it violates first normal form, or a relation is in first normal form if it does not contain any composite or multi-valued attributes. A relation is in normal form if every attribute in that relation is a single valued attribute. Okay, so if you remember, we actually included some arrays, so this isn't sounding good for us. So arrays versus relations versus tuples in first normal form. There's maybe hope here. Arrays bear some relationship to relations and tuples, but all 3 are different in significant ways, which means they are best at solving different problems. Like tuples, arrays are ordered. However, unlike tuples, every array element must have the same data type. This means that arrays of text can represent tuples of any type. Unlike tuples, arrays do not have a fixed number of elements. Elements can be added without disturbing the basic type. Like arrays, relations are basically rectangular and open-ended. Items can be added or removed from the end. However, arrays are ordered and relations are not. This means that an array value is a domain, while a relation value is a set or bag of domains, depending on constraints. All data types in an array must be identical. Relations do not have this restriction. What this means basically is that the mere use of an array in a column of a table does not necessarily violate first normal form if the array is used in a way that suggests that ordinality matters. For example, we could store matrices for matrix arithmetic as numeric arrays. We could store some problems that are transformed into numeric matrices into the database as well. For example, simultaneous linear equations, and these would not necessarily violate first normal form. So we have to pay attention to what it said up here. So ordinality matters. In our case, the order doesn't matter. We are just haphazardly listing these items in there in our sales. So we have GPU and monitor, GPU, monitor, CPU. There is no order in those values. So we are breaking the rule. So what we're going to have to do is we're going to have to deconstruct those arrays. It's going to be kind of a pain here, so I'll have to just kind of showcase why we should plan these things ahead of time and save yourself a lot of time and headache having to manipulate your database in such a way that it finally is in normalized form. Okay, so we find the values that have our arrays. So what we're going to do is we're just going to drop the column entirely, drop the column total items, because now we're just going to have one item for each row. We don't need both of those columns anymore. As we can see, we have dropped the two columns. Now we insert a new column called sales. We insert a new column into sales called item. It's going to be a varchar this time. We can see that that was added. So when we do our select all from sales, we see that these none values are there. So they're just acting as placeholders for this empty information that we need to add. So I had to go in, I had to find what the orders was up here, GPUs and monitor. So I added, I used the update row function we created. I want to insert into item GPU where the order ID equals 1. Also, I want to update the row of sales named in the column purchase total. I want to add the value 200 where the order ID equals 1. And then once again, inserting the rows, sales. So now I had to add another row. So that's just one item. Now I had to do the same thing over here for the monitor. That was including this sale here, GPU and monitor. So I'm going to have to do the same thing. Now make 3 more rows for this one. And so I did the monitor, and then there's the monitor and the CPU. So now that we've normalized it, this is what the table looks like. You can see that there's repeated information here, which represents the customer ID. And then each individual item is in its own row. So now we also need to handle the IT department where we had those skills, a list of programming languages. So we had to drop the column. So we use the alter keyword in order to drop columns. Whenever you're changing columns of a database, this is going to be your go-to, alter. So we drop the column skills. We insert the column skill. We're going to make that a varchar. So it's just going to contain one value. And for every one of these programming languages, now we have to make a new row. But the problem with that is that we have a primary key, which is the serial. It's auto-incrementing. It cannot be a duplicate. So now I have to rethink this. How am I going to be able to create multiple rows of the same employee, just the only difference will be that programming language? So what I have to do is I have to drop the constraint of the primary key. Drop constraint is basically deleting the type of primary key associated with that column. So what I'm doing instead of the primary key is I'm adding a foreign key to that employee ID. Now I'm saying these are the languages that remain. For language and languages, we're adding those new rows. And then when we've finally completed all that, we do a select all from IT department, and this is what we're left with. So we have the employee ID 333, and it's going to be the same information, same information, same information. The only difference will be the programming language. So second normal form. We must have reached first normal form. All columns in the table rely on the primary key. So what I did here is I just called our get column info, kind of take a survey of our information here and kind of see what the, does first name rely on employee ID? Yes. Does the position? Yes. Does the phone number? Yes. And it does look like we are reliant on the primary key. There is no basically unfitting information in our tables. So I believe we have made it to second normal form, and I guess I forgot to write that here. I can do that now. In case you're wondering how to use the markdown cells in Jupyter. Let's see, what did I do here? So I'm going to say 3 is going to be third normal form. And for third normal form, there must not be transitive dependencies. So what does that mean? Must not be transitive dependencies. A transitive dependency was like when we had to do our 2 joins. I believe what we were doing was returning the sales name, the total sales, but basically when we did those 2 inner joins, when we had to make 2 joins on a table, that is what's called a transitive dependencies. We're having to transport from one table to another one, or transfer, I guess would be a better word. So in our case, our database does not fit the requirement. We broke the rule of third normal form. We've only made it to second. So that's the showcase I had for you for creating a relational database. I hope what you guys took away from it was that planning your database is crucial. You must think of all of these things beforehand. What is the best organization strategy for creating it before you just dive in and start trying to do it off the top of your head? Because you may end up doing all of this extra code just to make up for it. So as you start learning about NoSQL databases, you may start to ask yourself, well, hey, wasn't this a better case for a NoSQL database? And I would argue, yes, it was, because we're going to be doing a lot of writing to this database. As purchases are made, we're making a lot of changes, and I believe that this would actually be a suitable candidate for NoSQL as opposed to SQL or a relational database. So next week when I hold the course, or I'm sorry, the webinar, we will be going over Apache Cassandra. I will remake this Acme Code database, but in a NoSQL form. And here's a resource here that I used for describing the normalization process. It's a very well written article. I recommend you guys check it out. In the meantime, I hope you guys enjoy your first week of the data engineering course. It's going to be a challenging 5 months, but definitely rewarding. Once you guys are made it over the hurdle, you will have some very in-depth knowledge of how databases are structured and how to assist you in your career going forward. Anyways, once again, thank you for taking the time, and if you haven't already downloaded this notebook, go to my GitHub link, which I provided in Slack, and you'll be able to download this and play around with it yourself. If you can't remember, how was it that I updated that date, or how did I access an array, you will have this as a resource for you now. And I look forward to getting to know you guys. Feel free to contact me on Slack at any time, and yeah. See you soon.